morning to everyone. Our today topic is three-dimensional printing. 3D printing is a form of additive manufacturing technology where three-dimensional object is created by laying down successive layers of materials. It's also known as additive manufacturing. 3D printing is achieved using an additive process where successive layers of materials are laid down in different shapes. It may be triangular, rectangular, or slicing an object as a unit. The technology for printing 3D objects from digital data was first developed by Charles Hull in 1984. He named the technique as stereolithography and obtained a patent from the technique in 1986. In the end of 1980s, other similar technologies as FDM, Fused Deposition Modeling, and SLS, Selective Laser Sintering were introduced. In 1993, MIT patented another technology named 3D printing techniques, which is similar to inkjet technology used in 2D printing. In 1996, three major products, Genesis from Sasys and Actua 2100 from 3D Systems and Z402 from Jet Corporations were introduced. In 2005, Jet Corp launched a breakthrough product named Spectrum Jet 510. The Spectrum Jet 510, which was first the high definition color 3D printing in the market. Additive manufacturing refers to technologies that create objects through sequential layering. Sequential layering means step-by-step layering. Rapid tooling, rapid prototyping is a group of techniques used to quickly fabricate a scale module of physical part of or assembly using 3D computer-aided design data (CAD) data. Subtractive process, removal of material by methods of such as cutting or drilling. Stereolithography were defined by Charles W. Hull as systems of generating 3D objects by creating cross-sectional pattern of the object to be formed. In a whole material, we subtract our required material means it's commonly known as subtractive manufacturing. We step by step add a material means it's additive manufacturing. This diagram clearly shows the difference between these two things. 3D printable models may be created with a computer-aided design package or via 3D scanner. The packages are ProE, SolidWorks, CATIA, etc. The manual modeling process of preparing geometrical data or 3D computer graphics is similar to plastics arts such as sculpting. 3D scanning is a process of analyzing and collecting data of real objects, its shape and appearance, and builds digital 3D models. The object is created in ProE software, which is shown in the figure. Rapid prototyping slicing. In this step, the whole object is sliced in this manner. Number of layers. The scanning direction is towards up to down. The three coordinates are shown here. To perform a print, the machine reads the design from 3D printable STL file. STL means structural triangular language file. These are some mistakes. It lays down successive layers of liquid, powder, paper, or sheet metal to build the models from a series of cross sections. These layers, which correspond to the visual cross section from the CAD model, are joined or automatically fused to create the final shape. Printer resolution describes layer thickness and XY resolution in dpi, dots per inch or micrometers. XY resolution is comparable to that of laser printers. The particles 3D dots are around 50 to 100 micrometer or 510 to 215 dot per inch in diameter. Though the printer produced resolution is sufficient for many applications, printing a slightly oversized version of the described project or desired project in standard resolution, and then removing a material from higher resolution subtractive process can achieve greater precision. Support Supports are removable or dissolvable upon completion of the print and are used to support overhanging features during construction. These are common additive processes. Extrusion deposition, it's commonly known as fused deposition modeling, granular materials binding, lamination, photopolymerization, mask image projection based on stereolithography. First step, FDM is an additive manufacturing technology commonly used for modeling, prototyping, and production of applications. FDM works on an additive principle by laying down materials in layers. A plastic filament or material wire unknown from the coil and supplies material to produce a part. Various polymers are used: ABS, acrolein butadiene styrene, PC polycarbonate, PLA polylactic acid, HDB high density polyethylene, PC and ABS combination, and PBSU. The diagram indicates nozzle ejection molten plastics. This part is shown deposited material. This is a controllable and movable table. Granular material binding. This technique fuses the part of layer and then moves the working area downwards, adding another layers of granulars and repeating the process until the piece has built up. The process used infused media to support overhangs and thin walls in the part of binding produced. A layer is typically used to sinter the media into solid. SLS is commonly known as selective laser sintering, uses layers as its power source to sinter powdered material, binding it together to create solid structure. SLM, selective laser melting, uses 3D CAD data as a digital information source and energy in the form of high powder laser to create 3D metal parts by fusing fine metallic powder together. EBM, electron beam melting. EBM manufactures part by melting metal powder layer by layer with electron beam in high vacuum. Lamination, sheet is adhered to subtract with a heater roller. Laser traces desired dimension of prototype. Lasers cross hatches non-part area to facilitate waste removal. Platform with the completed layer moves out of the way. Fresh sheet of material rolled into opposition. Perform moves up into the position to receive next layer. Process repeated. The structure indicates the LOM process. The foil is applied through the heated roller and it's heated under laser beam. Laser unit emits laser through scanning prism into the foil. Photopolymerization primarily used in stereolithography to produce solid part from a liquid. In digital light processing, a vat of liquid polymer is exposed to light from DLP projector under safe light conditions. The exposed light polymer hardens. The build plate then moves down in small increments. The liquid polymer is again exposed to light. The process repeats until the model has been built. Inkjet printer system like the object polyjet system spray photopolymer materials on the build tray in ultra thin layers between 16 and 30 micrometer until the part is completed. The stereolithographic process is shown in the figure. Mask image production based stereolithography. In this technique, a 3D digital model is sliced by a set of horizontal planes. Each slice is converted into 2D mask image. The mask image is then projected on photocurable liquid resin surface. Light is projected and the resin cure it in shape of the layer. The printers are shown in this figure.